Section 5.3 is all about writing equations of lines, and there are several different ways that we can write an equation of a line depending on what information that we know. Can you write the following formulas here? Slope-intercept form, do you know what that is? How about standard form? And what about the formula for calculating slope if you know 2 points? Alright, slope-intercept form, recall, is y equals mx plus b, where m is your slope and b is your y-intercept. What's standard form? Standard form's that alphabetical one. ax plus by equals c. And remember, we have some rules about standard form. No fractions. Needs to be in simplest form. A has to be positive. And then the order has to be correct. How about the formula for calculating slope? y2 minus y1 over x2 minus x1. Okay? So if we utilize these three formulas, depending on what we're doing, we would use different formulas. So the first type of problem here is where we want to write an equation of a line given the description. So number one, we have a description here where the slope is -4 and the y-intercept is 1. In this case, this is as easy as it can possibly get. We have our slope-intercept form equation right here. And if we know the slope is -4, we just put that in for the slope. And if we know the y-intercept is 1, we put that in for the b. So our equation is y equals -4x plus 1. And you're done. That's all you have to do. You know the slope, you know the y-intercept, so you can go straight to slope-intercept form. Now, if you're looking at number 2, there's actually no description. There's just a line graphed here. Number 2 is very similar to number 1 because what we want to do is extract the slope and extract the y-intercept from this graph. So, how can we find the y-intercept? If this is our y-axis, of course the y-intercept is going to be 1, 2, 3. Positive 3 because it's up. And if we want to find the slope, you need to find 2 points where it crosses the grid exactly. So this one is labeled for you. We'll use that one. And here's another one where it crosses exactly. There's actually one more right here where it crosses exactly. So you could choose any 2 points there, but we'll go ahead and use these two. So if you're starting at the left point, like we learned in section 5.1, we're doing floors over doors, so we go down 1, 2, 3, so that makes our slope -3 in the numerator, and to the right 1, 2. And to the right is positive, so that's going to be a positive 2. Once you know your slope and your y-intercept, then it's just a matter of plugging into the equation, just like this one. So these two problems are exactly the same, except we're given the slope and the y-intercept. If you're given a graph, then you extract the slope and the y-intercept, and then you write it into the equation. So y equals -3/2 x plus 3. Now, just a little note, this is called slope-intercept form because the first piece is slope and the second piece is y-intercept. So keep that in mind, that the first piece is always going to be the slope, the piece with the x. And then the one by itself is always going to be your y-intercept. So I want you to take a moment and see if you can figure out what the equation would be for number 3, number 4, and number 5 given the graph. So please press pause here, do these 3 problems on your own, and come back and check and see how you did. Alright, so let's see how you did. We have to identify the slope, m, and the b, the y-intercept. So the y-intercept is always going to be the easier piece because you just find the y-axis and you find where it crosses the y-axis, which would be -1. The slope might be a little more challenging, especially if you have to find your own points. Now in this particular line, it actually crosses at every single one of these points on the grid. So you can pick any 2, and if you pick 2 that are closest to each other, whether it's these 2, these 2, these 2, or these 2, you won't have to reduce the slope that you would if you picked two that were further away from each other. So let's go with this one and this one. If you start at the left point, you're going to take your elevator up one flight, so that would be 1 in the numerator, and to the right one flight, so that would be 1 in the denominator. And if you want to rewrite your slope as 1, you can. So if your slope is 1 and your y-intercept is -1, then we just throw it into the equation. Y equals 1x minus 1. And if you wanted to, you can write y equals x minus 1. Either one is possible, and they're both correct. Number 4, we're looking for the y-intercept and the slope again. The y-intercept, again, find the y-axis. It crosses at +2, so we have a y-intercept of 2. What is the slope of this line, this flat line? If you drive your car across it, how steep is it? Has no steepness, so it has a steepness of 0. Now there's a couple ways that you can do this problem. We can use this information and write an equation, y equals 0x plus 2, which is completely fine, but because of this 0 here, we would want to simplify this to, this will drop out because 0 times anything would be 0, so we get y equals 2. Now for some of you, you might have gone straight to y equals 2 because you notice that it's a horizontal line. Remember, if it's a horizontal line, if you flip that h for horizontal upside down, that's going to give you a y equals something. And we know that y equals 2. So this is a horizontal line. It's only going to have a y in it. And then you find what y is. Y is 2. So there's your equation. Whatever way you get to that equation is fine. And the last one, number 5, your slope and your y-intercept. The y-intercept is, of course, -1, 2, 3. And the slope, there's only 2 points you can choose, which are these two. So if we start at the left point, we take the elevator down 1 floor, so that's -1. And we go to the right 1, 2, 3, 4 doors to the right. So we get a slope of -1/4. Now keep in mind, you can double check your slope, at least the sign of your slope. If you're driving uphill, that should be a positive slope, +1. If you're driving downhill, that should be a negative slope, -1/4. And then we can put this into the equation. Y equals -1/4 x minus 3. Oops, went off the edge there. So when you're given the slope and the y-intercept, like in number 1, or if you're given a graph where you can find the slope and the y-intercept, these will allow you to go straight to slope-intercept form. However, if you do not know the slope and the y-intercept, exactly the y-intercept, you cannot start with slope-intercept form. So instead, you will have to go with a different form. You'll have to begin with a different form. So, for example, the directions say write an equation of each line given the point and the slope. Give your final answer in slope-intercept form. So notice, we are given the slope, but this is not a y-intercept, and this is why we cannot use the same method we did in the previous problems. So let's go to our Cornell notes, and we can start at the top, slope-intercept form. We know that's going to be y equals mx plus b, and go ahead and label this. This is your slope. This is your y-intercept. Okay. Writing an equation of a line given a graph, which is what we just did. The first thing you want to do is identify the slope, identify the y-intercept. Now these two things have to happen first, but it doesn't matter which order these two things happen. Once you've done that, then just plug into y equals mx plus b, slope-intercept form. This only works if you're given a graph or if you're given the slope and the y-intercept. So we need to talk about this new form called point-slope form. Point-slope form is going to be this: y2 minus y1 equals m times x2 minus x1. and m is still your slope. But you'll be given a point, x1, y1, that you'll plug into this spot, which is the second y, and this spot, which is the second in line, x. And I'll show you what I mean for that, okay? So if you are here, and you know the slope is -2 and it goes through this point, what you want to do first is write the equation. y2 minus y1 equals m times x2 minus x1. And this has to have parentheses. Now, this is your slope, -2. So in place of m, we put -2. Now, in place of the y1 and the x1, this is your x1, this is your y1. And the y2's will just become generic y's. So y minus the first y, or the one that we're given. Now, the y is -7. So the formula says to subtract, and then the y is -7. So we have a double negative going on here. And then this becomes x minus 3. So the formula is subtraction. So if you are subtracting a negative, you end up adding that value. So we get y plus 7 equals, and here it was x minus, and it was a positive 3, so it stays x minus 3. But in order to put this in slope-intercept form, we need to get rid of these parentheses, so we'll distribute this -2, which gives us -2x, and -2 times -3 will give us +6. We still have not solved for slope-intercept form because we have to get y alone. So we subtract 7 from both sides, and we get y equals -2x minus 1. All right, so let's write down what those steps are that we used here on your Cornell note sheet. Bring that back. Number 1, for now, until you have memorized the formula, you want to write the formula first, which I'll write it again. y2 minus y1 equals m times x2 minus x1. Once you've done that, then you want to plug in the m and the x1, y1. We need to then distribute on the right side and finish by solving for y, so that it's in y equals mx plus b. So those are your 4 steps. Let's go ahead and practice this some more. We'll do one more together, and then I'll have you try some of these on your own before you look ahead. So number 7 is through this point and has a slope of 1/2. Again, this is not a y-intercept. It's just a random point. So you cannot use slope-intercept form to begin with. You must use point-slope form. So start writing the formula. y2 minus y1 equals m times x2 minus x1. And the y2 becomes y minus your y value, which is 6, equals your slope, which is 1/2, times x minus your x value, which is -2. This will stay the same for now because we have to distribute first to get rid of the parentheses before we can move this 6 over. So this stays y minus 6. Distribute this 1/2. However, before you start distributing, let's go ahead and fix this double negative and make it into a plus sign. So we'll make it happy. So it's really x plus 2. So 1/2 times x gives us 1/2 x. 1/2 times 2 gives us +1. And finish solving for y by adding 6 to both sides. So we get y equals 1/2 x plus 7. If you think you have the hang of it, go ahead and try 8, 9, 10, and 11 on your own. And we will go through them here in a moment. If you get stuck on one, go ahead and move on to the others. They're not all the same. So 9 is a tricky one. If you get stuck on it, that's fine. Just continue on through 10 and 11. So press pause here and give these a shot on your own. All right, let's see how you did. Starting with the formula, y2 minus y1 equals m times x2 minus x1. We get y minus our y value, which is 0, equals our slope, which is 1/4, times x minus our x value, which is 2. We need to get y alone, which, luckily for us, y minus 0 is still y. But we want to go ahead and distribute this 1/4. So 1/4 times x was 1/4 x. 1/4 times negative 2. Let's do this over here. 1/4 times negative 2 over 1. We can cross reduce here, so 2 goes into 4 twice. And so 1 times this negative 1 that's left over would give us negative 1 on the top, and 2 times 1 would give us 2, so minus 1/2. The other way you can do it, if you don't want to cross reduce, if you do 1/4 times negative 2 over 1, multiply across the top, which gives you negative 2, multiply across the bottom, which gives you 4, and then you need to reduce that, and that still becomes negative 1/2. So there's our equation. Y equals 1/4 x minus 1/2. So the slope is 1/4, and the y-intercept would be the point 0, negative 1/2. How about number 9? It goes through this point, negative 6, 4, and it has an undefined slope. Now, think about your car. If you're driving your car up a hill, up a wall, that's undefined. So, undefined slope, it can't be given a number. So, you can't use this method here because it can't be given a number, so you have to come up with a different way. Now, if it's a vertical line, what do we know about the equation? If it's a vertical line, it must be an x equals something. And what is the x in this point? Negative 6. So if we know that it's undefined slope, think about the car driving up a wall, which is impossible. Okay? That gives us a vertical line. A vertical line means we have an x. Remember, the v fits down inside the x. And x equals the x value in the point, negative 6. So there's your equation, x equals negative 6. So you don't have to go through point-slope form at all. You actually can't go through point-slope form. This is the only way you can go. If you haven't tried 10 and 11 yet, try those on your own, please, before you continue on. So let's see what happened with 10. Start with the formula. y2 minus y1 equals m times x2 minus x1. We get y minus the y value, which is negative 1, equals the slope of 0 times x minus the x value, which is negative 2. These double negatives we should fix and make them plus. So we get y plus 1 equals, fix this. Now, 0 times x is going to be 0. 0x if you want. And 0 times 2 is going to be 0. So what we end up with, 0 times anything is going to make this whole side drop out. 0x is nothing, 0 is nothing. So we get y plus 1 equals 0, basically. We have to solve for y, so we subtract 1 from both sides, and we get y equals negative 1. Now, you could have skipped all of this if you recognize that a slope of 0 would be a horizontal line. And a horizontal line would be a y equals something, and the y value is negative 1. So basically, if we use the same skills we used in number 9, anytime the slope is undefined or has a slope of 0, then you can take this shortcut. Now, in this case, this is the only way you can find it, but if it's a slope of 0, you can either go the long way or you can take the shortcut. Again, a slope of 0 means it's got to be a horizontal line. If you flip that h upside down, it would give you a y. So y equals negative 1 would be your answer. And finally, number 11. This one's trickier because of the fraction. So let's see how you did. y2 minus y1 equals m times x2 minus x1. We get y minus 4 equals negative 1/3 times x minus a negative 10. So we can't do anything here on the left side yet. Y minus 4. This is easy. Negative 1/3 x. Now negative 1/3 times, fix this, positive 10. The easiest way to do this is just to throw this 10 over 1. Now imagine all you're looking at is this. Negative 1/3 times positive 10 over 1. So we know a negative times positive will make that negative. Across the top we get 10. Across the bottom we get 3, so negative 10 thirds. Now this is perfectly fine. However, it might be easier when we do the next step, which is adding 4 to both sides, if we had this as a mixed number. So what mixed number would that be? 10 divided by 3 would be 3. It's still negative, so negative 3 and 1 left over. So we've added 4 to both sides. We get y equals negative 1/3 x. That part's easy. Now, you have a positive 4 and a negative 3 1/3. So I think of cookies. If you have 4 cookies and you take away 3 and 1/3 of this one, that's going to leave only 2/3 of this guy left. So we have positive 2/3 here. So one more time. Multiply across the top, which gives you 10. Multiply across the bottom, which gives you 3. 3 goes into 10 3 full times with 1 left over, so 3 1/3. The positive, or the big guy, start with him first. 4 minus 3 1/3 is going to leave just 2/3 behind. So, just to recap, writing an equation of a line when you're given the slope and the y-intercept, or when you're given a graph where you can find the slope and the y-intercept. In that case, you can use slope-intercept form. But if you know the slope and some other point besides the y-intercept, then you have to start with point-slope form because you have a point and you have a slope, and continue through until you get to slope-intercept form.